Okay, so hello to everyone. Thank you for being here with us. Today we have Mathieu Steijn, who is affiliated with University of Utrecht and University of Vrije of Amsterdam. And he will present us his paper about co-agglomerations. And Mathieu, do you want to start sharing your screen?
Yes, sure.
His research interests are about agglomeration, spatial inequalities, technological progress, globalization, and at the moment he's PhD student, University of Utrecht, expected to graduate this year, and he has 1 year contract, and for next year he will start again to apply for jobs. So without any delay, the virtual floor is yours, Mathieu.
Thank you, Georgios, for the introduction, and thank you for having me. So yeah, I'm Mathieu of the Vrije Universiteit Amsterdam, and I also work at Utrecht University. And this is joint work with Hans Koster and Frank van Oort, also in the Netherlands. And I think my paper fits very well with the research I've seen at the few visits I've made to Barcelona. I'm, like most of us, very much interested in the unequal spatial distribution of human activities across space. So in the background you see a graphic that really shows how the employment distribution has changed in the United States. And in this paper, I'll be very much focused on the reasons why people are together. And it's a bit paradoxical to do that online, because we're all interested in geographical proximity. And well, the Corona crisis shows how difficult it is to do things online, but I hope I'll get most of the knowledge spillovers through. So a bit of context. So, well, you're probably familiar with the work on by Moretti, the Great Diversion since 1980. So before 1980, income levels and human capital levels between regions were converging, but then after 1980, they started diverging again. Some cities grew much faster and others lost out. So at one hand, you have the triumphing cities, as Glaser would put it, and there you have issues on high rents, gentrification, and you see those are the places that win out. Well, Barcelona or my city of birth in the background, Amsterdam, are, I think, perfect examples of places where you can see the distress caused also by the growing need for concentration. And at the same time, you see regions in the innerlands of countries. So think of Detroit in the US, Amiens in France, and previously industrialized regions that have lost out, and where you see issues of non-employment, which is worse than unemployment, and rising premature mortality, and of especially young men, partly due to suicide, but also due to unhealthy behavior. This has also been linked to political polarization. The Brexit vote, Gilets jaunes, the votes for Trump. If you look at it, there's a clear geographical component to this. So I think that the research we do is more relevant, maybe more relevant than ever. If we look at all the research on why is concentration more important, then we see that most evidence is a lot on countering the death of distance. So there's a lot of evidence that what we do now, so this online presentation, is not a substitute for face-to-face contact. Well, probably a lot of you know this in online meetings, but if you're teaching, I notice it myself, it's harder to get ideas across. It's less well to develop trust. So that is an indication that in times that of global integration, proximity still matters. Well, another line of research is very much a bit of a circular reasoning, in the sense that we see a concentration of activities in times of global integration. And then as a proof, we show that agglomeration is actually increasing, and specifically those that are knowledge intensive and that could actually maybe use computers to communicate. And there's another line of research that shows that distance remains important in trade, so in gravity models, etc. But if you think of changes in agglomeration patterns, then one of the things that comes to mind is actually thinking of changes in agglomeration determinants. If we go back to Alfred Marshall, who classified the benefits of agglomeration into 3 sources, then a logical answer is asking what has happened to the importance of labor market pooling, input-output linkages, and knowledge spillovers over time. So feel free, by the way, to interrupt if I'm unclear or anything. It's I don't see your faces while presenting. And so measuring actually the forces of Marshall was pretty difficult because each agglomeration force leads to productivity gains when you're agglomerated. So disentangling which force matters more was thought to be impossible due to the Marshallian equivalence. They all lead to productivity gains. What Ellison, Glaser, and Kerr do is actually look at co-agglomeration. They look at the extent to which 2 industries are together and then regress that on proxies for the extent to which they can share workers, share ideas, or share input-output linkages. So if you're very often together with an industry with who you can share workers, then probably labor market pooling is very important for you. And that's what they show for industries in 1987. Building on this work, there's Fagio et al. Have 2 papers out, and also Dario Diodato with co-authors that show that there's a great heterogeneity between industries in co-agglomeration preference. So not every industry values labor market pooling equally. So where Ellison, Glaser, and Kerr were cross-sectional, they show there's a great heterogeneity. This heterogeneity is also important for this paper because if there's differences between industries, there must also be differences over time. And then if you think of differences over time, then you have to know that co-agglomeration patterns change through changes in establishment composition within industries and locations. And some major forces are trade, technology, and transportation costs. So I put them under 3 T's. The Great Diversion started in 1980, and this actually is around the time of the computer revolution. The computer made people like you and me that do knowledge-intensive work more productive. It's a complement to our work, but actually it replaces workers in routine activities. So management tasks, or if they work in factories, if you work in production activities. At the same time, there's also the technology also allows for work to be offshored, and in combination with trade agreements, this has led to trade competition, notably the entrance of China. This also impacted the establishments because we see that those that are producing standardized labor-intensive low-tech products, so basically the same products as Chinese competitors, they are being pushed out, while those that are very much catered, customized to a niche market, both in settings as in timing, they thrive better. So in general, we see that there's trade and technological progress led to more capital, knowledge, and skill-intensive manufacturing world. And then there's also transportation costs. Marshall also argued that firms can co-locate to save on the transportation costs of people, goods, and ideas. That's actually where he got his 3 sources of agglomeration benefits from. Edward Glaser and Janet Koolhaase show that the transportation goods have decreased and that of people have actually increased. And the transportation cost of people is mostly due to the rising opportunity cost of time. So these forces are likely to have played a huge role in the changes in agglomeration patterns that we already know. And in this paper, I'm going to see if they also have an influence on the changes in agglomeration determinants. There's a lot of debate on how these have changed. Here I have a short survey of the literature. So on labor market pooling, Moretti says is that probably become more important because you want better matching between firms and employees. Input-output linkages, there are diverging views. So at the one hand, Glazer and Koolhaase say transportation costs of goods have decreased, so input-output linkages are probably less relevant. At the other hand, other authors suggest that the coordination costs have increased because you want customized, flexible production activities. And then knowledge spillovers are probably the most important force of today. If you read the literature, then you see a lot of speculation on ideas are the currency of our age. However, this has actually not been measured yet. So far, we have this circumstantial evidence that I discussed in the beginning. If we look specifically at the results of Vrije et al. That already did a co-agglomeration analysis, we get further hypotheses. They show that low-tech, low-indication industries value labor market pooling and input-output linkages, and high-tech, high-indication industries value knowledge spillovers. They link this to the nursery theory in the sense that when you're in the product development, you make a product that you compete on customization and niche, then you require a lot of knowledge spillovers, but when the production process and the product are standardized, you switch to labor market pooling and input-output linkages and you compete on price. So if we know these results, then we would expect that the relevance of labor market pooling and input-output linkages decrease and that of knowledge spillovers increases. So again, this contradicts some of the other theories we just saw. So that's the context of this paper, and I'm going to proceed in 3 steps. So first, I will replicate the results of Allison, Glazer, and Kerr and the others in co-agglomeration, but then with my data. Then I will see measure over time if there are changes in the relevance of labor market pooling, knowledge spillovers, and input-output linkages. And in the third step, I will test if trade, technology, and transportation costs are associated with these changes in these determinants of industry agglomeration. So let's start with the data. I use county business patterns from 1970 to 2014 for 140 SIC manufacturing industries at the Metropolitan Statistical Area level, so MSA level. The most important formula is the dependent variable and is the co-agglomeration between industry I and industry J at time t. This is dependent. This is measured by the share of industry I in city M at time t, and this stands for the share of that city in the total employment. So let's say that industry I has 15% of their employees in that region at that time, and the city is only 10%, only has 10% of national employment. Then this term, where's my mouse? This term becomes positive, and this term becomes positive. And if industry J is also overrepresented in the same area, then both are positive and the co-agglomeration turns positive if you're often together in the same areas, overrepresented in the same areas. If you're both underrepresented in the same areas, it's also positive. So that's how the co-agglomeration index works. And then we regress that on data for the extent to which you can share workers. For that, I used the National Industrial Occupation Employment Matrix. So the data of 1970 and 1977, I obtained them through OCR. So if you're interested in that, I put them on my personal website because you cannot find them online. All the data I used are open source data, so there's nothing classified in this data. So that also makes it really interesting. And the measure of labor market pooling is the correlation in shares of job occupations. So per industry, the share per job occupation, and if you have a lot of your workers in the same job occupation, then the correlation is high, and then we say that you can share workers, so your extent to labor market pooling is also high. Then input-output linkages, that's based on the use tables of the Bureau of Economic Analysis. And I input, so the inputs of industry I received from industry J are measured as the share of inputs obtained from industry J. So if you receive a large percentage of your goods from industry J, then the input linkage becomes very strong. And the output is how much you sell to industry J. So how the share of products industry I sells to industry J. And then I take the maximum of those two values to give a measure of the input-output linkages. Note that how important industry J is to you in terms of input-output linkages is not the same as how important industry I is to industry J, because you obviously sell to other industries. So this measure is directional, whereas the Co-agglomeration Index is the same whether it's IJ or JI, and also labor market pooling is the same, IJ, JI. For knowledge spillovers, we use the data from the NBER and Sergio Petralia. And we use the classification of the concordance of William Kerr to classify concord classes from USPTO to SIC 87. The patent citations are the share of patent citations industry I makes to industry J. This is the measure that most of the literature uses so far. We decided not to use this measure, first of all, because not all the citations, not all the patents that you cite, not all the technologies that are on the cited patents are used in the patents that are relevant to you. So some of our industries some of the patents cite up to 1,500 other patents, so that leads to a lot of superfluous correlation between industries. And also the share of patent citations of industry I to industry J is not normalized by the size of industry J, in the sense that there are a few industries that patent a lot. So by definition, a great share of the patent citations goes to these industries, even though they are not that relevant. So we use technological relatedness, and that's based on a network probability measure based on the co-occurrence of industries on patents. So there are multiple technology classes on a patent, and based on which technologies are put together, you know which ideas are actually used in an invention and are relevant. So if you're interested, there's a paper on Cesar Hidalgo by Cesar Hidalgo and many other authors on how relatedness is a very useful measure. And then I have a paper myself on how to actually calculate relatedness. And obviously the usual disclaimer applies that not all knowledge spillovers are captured by patents. I hope so far everything is clear. Great.
Yes, everything's clear.
Great. So here you see an overview of the different years used. So due to data limitations, there's data about from 1970, 77, 89, and then in steps of 5 years to 2014. Here are some descriptive statistics. So I explained the most measures here, and then I also add dissimilarity indices. Dissimilarity indices are used because sometimes you are not together because you rely on, so sometimes two industries are not co-agglomerated because they are dependent on each other, but maybe because both of them are very dependent on inputs of a particular sector. So for example, maybe two industries are always co-located because they're always next to coal mines. Yes?
Sorry, Mathieu, there is a question from Adonio. So Adonio, go ahead.
Thank you, Georgios. Maybe next time you can leave the speaker talk until the end of the sentence. But my question is this the pooled evidence, right? So it's not, so it's the overall variation, is it? Or because
I'll go to the specification in a bit, but I pulled the data indeed of all the years, and I use between variation because there is a lot of measurement area, so I don't use within variation in the end.
Okay, so in this table, so this is just the between.
Yes, well, this table's the descriptive statistics of the entire data set, but okay. I'll show the specification in a bit, and then you can see how I use the data.
Okay.
So if just to finish the explanation on the Dissimilator Index, so you can imagine that sometimes two industries are always next to a coal mine, so that it doesn't mean that they are co-agglomerated because of labor market pooling of input or input-output linkages, but they are co-agglomerated because of that coal mine. So these are indices that take those kind of dependencies into account. So I hope this clarifies your question, Antonio. So what I do is I regress, in the first step, I regress co-agglomeration between industry I and industry J at time period T, on the extent to which they can share workers, have input-output linkages and technological relatedness, plus these 7 dissimilarity measures, and then I add industry times year fixed effects. So I also have a table, if you're interested in the end, where we use industry pair fixed effects, because then you would use within variation. However, you can imagine that all these measures, they are very prone to measurement error. And if you look at within variation, then these are amplified. So we do find similar results, but not as not as strong as the main results. But I can show it in the end if interested.
So it's clear, but then I was wondering if there is too much collinearity between the different dissimilarity indexes that you include.
Oh, between the dissimilarity indexes, not. But and also, well, we checked, and there's actually not that much. Wait, I can go back a slide. So you can imagine if you're both very dependent on agriculture, you're not both very dependent on mining. So actually, there's not, to my knowledge, there is not a strong multicollinearity between these. But I can check for that. No, it's not because it's not as if these are all the industries. So it's not as if it's like dummy variables. But I understand your concern. Next to the main specification, we also run instrumental variables. So you can imagine that sometimes industries are not co-agglomerated because they share workers, but maybe for random reasons in history they become co-agglomerated, and then because they were together they started to using the same workers. So to counter this, I use instruments based on data from areas where one industry is present but the other is not. So there you know that the type of workers used cannot be influenced by industry J because industry J is not present. We have this data for labor market pooling and for patterns, but unfortunately not for input-output linkages. And I use a more novel approach based on a paper by Emily Oster. And she introduced a way to control more strongly for omitted variable bias. So basically what it does is when you add control variables, so in our case the dissimilarity indices, then based on the changes in the coefficients and the changes in the R-squared, it estimates the effect of other control variables that you cannot observe or cannot measure, and therefore you even further reduce omitted variable bias. So here are I hope this is clear to everyone. These are the baseline results. So in column 3, you see our preferred specification. So with the dissimilarity measures and the industry by year fixed effects, all variables have been standardized and to have mean 0 and a standard deviation of 1. So that means that if the extent to which two industries can share workers increases by 1 standard deviation, then the extent to which they co-agglomerate, so the co-agglomeration index, goes up by almost 0.2 of a standard deviation. We see that input-output linkages and technological relatedness are less relevant, and this is slightly different from Ellison, Glaser, and Kerr, who found stronger effects of input-output linkages and less of knowledge spillovers. However, they use data of 1987 and they use patent citations. If we go to column 4, so the column next to it, you can see that if we use patent citations, then indeed input-output linkages seem more relevant. If we use both measures, so technological relatedness and patent citations, then technological relatedness stays virtually unchanged, and the one on patent citations goes to 0. So to us, this also shows that empirically, knowledge spillovers are better captured by technological relatedness than by patent citations. I'll leave the other columns for another time, but you can see that they more or less they agree with the main specification. The most interesting step, so now that we looked at replicating the results, now we're interested in seeing how it changes over time. So if you do this by year, then you get this table. And to make it more visually attractive, I put it in a graph for you. And here we can see that the coefficient on labor market pooling in 1970 was a bit more than 0.3, and it slowly decreases over time and then stabilizes from 1990 onwards. Input-output linkages start less high, but they show a strong drop, and it's almost no longer statistically significant in 2014. On the other hand, we see that knowledge spillovers have gained in importance. We see that technological relatedness, the coefficient, is close to 0.1 in the 1970, and then increases over time. So if you use interaction terms to control for these trends, then we find that these results are the trend is statistically significant. I have some backup slides if someone's interested in that. So this is actually one of the first proofs that knowledge spillovers as an agglomeration determinant has become more important. And now the next step is to try to explain why we see these changes in agglomeration determinants. So, as I said, agglomeration patterns are known to have been influenced by changes in trade, technology, and transportation costs. Therefore, we develop proxies for these forces. So for import penetration, we look at the share of inputs from low-wage countries compared to high-income countries in a certain industry at the time T. Following the work by David Otter, you can calculate the routine task intensity of each job. So they have a measure of routine task intensity, manual task intensity, and abstract task intensity. And those with a very high RTI, those are classified as routine employment. Routine employment is replaced by computers. So the decrease in routine employment shows the technological progress in industries. And then there's another explanation, those by Edward Glaser and Janet Koolhaase. And from this, that's the transportation costs have decreased of input-output linkages. So we saw a decrease in input-output linkages. So on one hand, the results by Faggio would suggest this is because industries are becoming more like the early stage of the nursery city, so they become more knowledge intensive, so they are less reliant on standardized input-output linkages. But we also have the explanation by Edward Glaser, and that's that input-output linkages have become less relevant because the transportation costs of goods are not so relevant anymore. So to measure this, we use the Iceberg transportation cost approach, and that's the share of expenditure on transportation in the use tables by the Bureau of Economic Analysis. Some descriptive statistics. So note that the number of observations is 1120 because we will determine how important every agglomeration determinant, the importance of every agglomeration determinant for every industry in every time period. We do this, just to show that indeed we see in the data that trade competition goes up. So we see that the imports from low wage countries in 1970 are on average for close to 0% and then go up to 35%. The routine employment share on average per industry decreases over time, which is in line with that the computer takes over jobs. And if we look at the expenditure of transportation costs, then as Edward Glaser and Janet Koolhaas would predict, it goes down over time because the transportation costs of goods decrease. So we use a two-step methodology. So we use the coefficients that we obtain in the first stage, which is very similar as our previous regression. So once again, we have the co-agglomeration of industry I and J at time t, and then we regress it per industry. So we obtain industry-specific coefficients. So for each industry, we have a coefficient on labor market pooling, which is alpha, a coefficient on input-output linkages, and a coefficient on knowledge spillovers for each industry and each time period. Then in the second stage, we use these as dependent variables. So your coefficient on labor market pooling, for example, we regressed of industry I and time t, regressed on these industry characteristics that we discussed just, so trade, technology, and transportation costs. Because we use this approach, we bootstrap standard errors in the second stage. You can also run the two steps at the same time by using interaction variables. These give similar results, but we also want to develop instrumental variables, and that's why we prefer to use this two-step methodology. But it makes no difference in results. There's also backup slides on that.
Mathieu,
yeah?
Sorry, there is a question.
Yeah. So I was just curious about why you use bootstrapping in a standard error. So I understand that the outcomes are generated variables, but you don't have any generated covariate.
So we bootstrap the standard errors in the second stage because the coefficients on each agglomeration force also has its variance of their own. And that's why we bootstrap the standard errors in the second stage.
Okay.
We also here we use instrumental variables because this paper I've started in 2016 and it's now at the under review at Journal of Urban Economics. So I've already sent it to AER and other journals. So I've already had a lot of comments, and one of the issues they brought up was that maybe if you're very strong in, for example, labor market pooling, then you want to offshore production, and then actually a strong labor market pooling coefficient leads to import penetration and not the other way around. So following the work by Author et al., we use import penetration in other high-wage countries, which are set in different time frames. So we use import penetration in a few European countries. Then the routine employment share, we can also calculate how much routine employment workers you have in areas where you're not co-located to make use of labor market pooling. So this is a bit similar as the spatial instrument before. So in areas where you're not together with industries where you can share workers, how many routine workers do you have there? Because that's not determined by the fact that you're co-agglomerated to make use of labor market pooling. And the problem with the share of expenditure on input-output linkages is obviously that if you spend a lot of money on transportation costs, then it's maybe because you have weak input-output linkages. So there the influence goes the other way around. And to counter that, we also based on Glaser and Koolhaas, we use the mean value of a ton. The mean value of a ton is not influenced by your transportation cost, but if you have a very expensive product, let's say a laptop, then the share of expenditure on transporting it becomes not so relevant. Whereas, for example, if you have, for example, there is concrete is in the manufacturing industry, and in concrete, the product value per ton is very low. So transportation costs can easily make up 45% of your expenditure when you purchase concrete. And we again use the bias adjusted estimates following Auster. And this time based on control variables based on the average establishment size and capital labor ratio. Some descriptive statistics on the coefficients. So on average, we see that the mean on labor market pooling is similar to those in the earlier table. That on technological relatedness is pretty strong, but it's mostly because of a few outliers. The median is a bit lower. So these are the dependent variables. This is an overview of the results. So we do not add transportation costs for labor market pooling and technological relatedness because this is not a reason to expect changes in labor market pooling and technological relatedness. We do show it in a later table. What we find is actually that import penetration is strongly and negatively associated with labor market pooling. Again, variables are standardized to have mean 0 and a standard deviation of 1. And so this here suggests that an increase of a standard deviation in import penetration leads to a decrease in the labor market pooling coefficient of minus 0.042. So the labor market pooling coefficient is obviously not standardized because it's already obtained from standardized variables. The routine employment share is strongly positive. So this suggests that if you have a lot of routine employment, then labor market pooling is more important. And if you have little import penetration, then labor market pooling is important. So this is a bit in line with the idea that trade and technology have replaced establishments that are labor intensive and low technology intensive. And that because the industries have become more knowledge intensive, the trend in labor market pooling is explained. As you can recall, labor market pooling has become less important over time. This is confirmed by our bias adjusted approach and our two-stage 2SLS approach. For the input-output linkages, we see that the routine employment share and the transportation costs are irrelevant. So transportation costs do not determine the decision to co-agglomerate to make use of input-output linkages. We do find stronger coefficients on input penetration. So this suggests that input penetration has reduced the relevance of input-output linkages. Here, with knowledge spillovers, we can see actually contrasting coefficients compared to labor market pooling, which is to be expected as knowledge spillovers actually have become more important. So we see that if there's more trade competition, then the remaining the establishments co-agglomerate more strongly to make use of knowledge spillovers, which is in line with the nursery city theory and is in line with the rising trend in knowledge spillovers. The same goes with routine employment share. So if there is very little routine employment, these workers that can be replaced by machines, the knowledge spillovers are not so relevant. However, if it's a high-tech industry with a lot of with more flexible workers, so less routine workers, then knowledge spillovers become strongly important. To get a bit more feeling of these results, I also have here some more industry characteristics. So the base characteristics show the preferred specification that we saw earlier. Here we added average establishment size and capital labor ratio, and we added R&D per employee. And in line with, these are particularly interesting, in line with the idea that knowledge-intensive industries require more knowledge spillovers, this is strongly statistically significant, positively with knowledge spillovers and negatively with labor market pooling. So it confirms to our idea that these high-tech, flexible industries rely strongly on knowledge spillovers and less on labor market pooling. Interestingly, this does not hold for input-output linkages. So where Fagio et al. Also suggested input-output linkages become less relevant if you're standardized, this doesn't seem to be the case because all these variables on high-tech are not that relevant. The only one that is input penetration, which is supposed to lead to the closure of standardized firms, but it also leads to substitution of input-output linkages. And that's why we think that the idea of the nursery city is strongly relevant for labor market pooling and technological relatedness, because also other industry characteristics that indicate high tech, high knowledge intensity are not relevant for input-output linkages. So here we think that substitutes from low-wage countries are actually driving the relevance of input-output linkages. So if you do not have many substitutes from low-wage countries, then you're closely co-agglomerate to make use of input-output linkages. However, if you can get cheap substitutes, then input-output linkages become a less relevant reason to co-agglomerate. Very shortly, because I see I'm a bit running out of time. Here we see a bit more investigation of these input-output linkages results. So if here we have the input penetration measure and routine employment share, transportation cost. This is the same result as we saw earlier. If we replace transportation costs by the value of a ton directly, then it's still not statistically or economically significant. This to us suggests that transportation costs of goods are not very important in co-agglomeration decisions when you want to make use of input-output linkages. If we use, on the other hand, the input penetration, the inputs, so the input penetration at this moment is the share of low-wage substitutes from low-wage countries in your industry. So that's the same product as you sell, so it mainly influences the output linkages. But if you look at the input penetration in the inputs, then you get similar coefficients, although they are not statistically significant, they are not statistically significantly different from the ones in input penetration. So that suggests to us that input-output linkages are really influenced by the substitution effect of input-output linkages of trade competition and not by the displacement of the low-tech, labor-intensive establishments, as is the case of labor market pooling and knowledge spillovers. So to wrap up, I think this paper really shows that we should not only think of changes in agglomeration patterns, but also take a more critical look at the changes in the relevance of agglomeration channels. This paper shows that there are equally impressive changes at this level. What's specifically shown is that indeed ideas are the currency of our age, so knowledge spillovers have gained in importance, where input-output linkages and labor market pooling have decreased in importance. We argue that trade competition and technological progress have influenced the knowledge intensity of industries by closing down the establishments, disproportionately closing down the establishments that are labor intensive, routine intensive, make standardized products, and therefore knowledge spillovers have become more relevant and labor market pooling has become less relevant. For input-output linkages, however, we suggest that the reason is that there are cheaper alternatives from abroad. Maybe some idea for future research. I think so agglomeration channels are a very important way ahead, especially with more and more data available at the micro level. While the classification of offered Marshall is not perfect, most of you are probably more familiar or want to use the classification by Duranton and Puga on matching, sharing, learning. However, there are still no measures to capture these proxies. Another way is is to think of, if we're interested in spatial inequality, a lot of interest is in the productivity gains of different channels. So in this case of labor market pooling, knowledge spillovers and input-output linkages. But it's also, I think, very important to be aware of knowing who has access to this channel. So if knowledge spillovers are more important, as this paper suggests, then we should also think about the people that have access to these knowledge spillovers and who doesn't, especially within regions and between, particularly within and between regions, because I discussed at the beginning, we have a strong rise in spatial inequality both between regions as within cities. I thereby conclude my presentation. Thank you very much for listening. I hope everything was clear and I didn't speak too fast.
Thank you very much, Mathieu. And now we are ready to receive more questions from the audience, if there are many. So I don't see questions. So I have one. Antonio, do you want to?
Yeah, okay. Well, it's more a technical question because, you know, with this approach by Emily Oster has been recently criticized quite a lot. And
okay.
I will send you a couple of papers during the evening. I need sometimes to recover them. But I was wondering if you try to check what happens if you change the delta parameter, which is for me a kind of black box.
Yes, to be honest, I think the Oster, so the Oster edition was mostly by Hans Koster, who was very, who was a bit more familiar with these methods. To me, the delta parameter is indeed very difficult to understand. As well, we didn't play around with it much. We tried to follow so they suggest to put it at 1, and if I remember well, the delta coefficient determines the relation between the expected R squared and no, I now realize that it's been a while ago. Antonio, can you recall what the delta coefficient was supposed to do?
Not specifically, but it's something related to the expected bias that you have in the coefficients.
Yes.
The coefficients that you do estimate.
Yes. So basically, we followed their approach and put it equal to 1. because that was what was suggested. We did not play around with it, and to be honest, I find it a bit tricky to understand exactly how it influences the result. But I think we should go a bit more into it. For us, it was mostly to check up if the results hold, if you put a bit more stress on the assumption that you don't have omitted variables. You can imagine that in these long time frames with very crude proxies, you leave out a lot of observation, a lot of noise that you cannot capture perfectly. And given that following the baselines of the suggestions of Emily Oster, that we get similar results, for us it was a kind of recomforting, and also for the referees.
No, that's why, but maybe, so from my point of view, my personal experience is that the results, or at least at the time I tried with this approach, change very much when you modify the value of that.
Yes.
But maybe, so if you, at the end, your results are very stable, or in general stable when you use ID. So perhaps you could kind of put more importance to the ID stuff and less to the Oyster approach.
Yes, well, in the paper itself, we put more emphasis on the instrumental approach. It's we also have a lot of discussion here between people how effective it is really at estimating omitted variables. I do think it's something that we should take into account, and we all know that they can pose a risk, but I'm open to new suggestions.
Thank you.
Thank you, Adonio. And I have also one question, Mathieu, if we have time. So I was wondering, you used expenditures to control for the transportation cost, right? If I
the share of expenditure on transportation enterprises. So you can see of each manufacturing industry how much they spend on, for example, railroad services, or motor truck services, or airplane services. And then I also have a data set on private truck use per industry per time period, so that I can control for the fact that in 1970 they use more private trucks, and nowadays it's more outsourced.
Okay. So these are the expenditures of the firms, or if I didn't
of manufacturing industries. So it's at the manufacturing industry level. So it's the share of so I put together how much expenditure is being made to firms that offer railroad services, airplane services, or trucking services. And then you see in 1970 that on average 6% of all the inputs that an industry has is spent on all those on transportation services. And in 2014, this share of expenditure is closer to 1% by heart. And this indicates to us that, as Edward Glaser and Janet Koolhaas state, that transportation costs of goods have decreased.
Okay, thank you.
You're welcome.
Very much. So if there are not any other questions, maybe.
So the paper, maybe just so the paper is now under review at Journal of Urban Economics, but most of the data that I use is freely available, and I put a part of it, the ones that are not available but I made myself, I put them on my personal website. So if people are interested in working with this data, then you can always give me a call.
Yes, sure. Thank you. Thank you very much. So let's conclude now. Thank you very much, everyone, for today, for joining us, and thank you also, Mathieu, for your nice presentation.
You're welcome.
I hope the next time you will be able
in Barcelona.
Come to Barcelona in person, and we will have some drinks there also. So thank you again, everyone, and have a nice day. And we keep in touch.
Bye.
Bye.